Okay, we're recording again. I wanted to welcome everybody to SQL Basics Week 3. I know some of you are just joining us for the first week, and I wanted to remind everyone that I am recording every single one of these, and so far that's been 2, and they seem to work. The video quality isn't perfect. The sound quality certainly isn't perfect, but that's probably my own fault for talking all gruffly. But if anyone would like to see the videos and cannot, please get in touch with me. I've got them up on the corporate Dynamic Campus SharePoint site. I've got them up on the CWI SharePoint site, and I've got them in a file share at UMary, soon to be on their SharePoint site as well. And I'm happy to help anyone else get access to these recordings. They are free and they are yours as long as you work at Dynamic Campus, I guess. So this week we are going to talk about a few things. One is we'll bring up the previous week's homework if you want. I've gone ahead and done all of the homework that I have assigned so far. Kind of a pain to do because it's not real. Much better to do real world stuff, but I've done it all. So if anyone has questions either during the course or later, just let me know and I can help out. I will recap the tables that I have in my test database, and we will pretend that select statements are tables. You'll see what I mean in a minute. And then we will get into joins. So this is kind of what everything has been leading up to. With this class and then the following class where we discuss aggregate functions, summing and minning and maxing and all that stuff, with all of that you will be super powerful at SQL and be able to at least understand just about everything you see in your reporting applications and just generally in the wild. So this is the core stuff. One of the things, though, with joins, in prepping for this class, I realized that there's a lot of stuff. So we might actually split this into 2 classes. We'll see how this one goes. There's just quite a bit to cover here. One other thing, in talking to Javed, welcome Javed. What I think I'd like to do at some point, and Javed's going to help me when he has some time, is, I've provided that class, that online sort of SQL laboratory thing at SQLzoo.com, and that's nice, but a lot of my course material focuses on some fake data that I have made, and what we might do, which Javed's expressed an interest in doing, is maybe spend a course or some other time going over installing SQL Server on your own machine, if you so desire, and then making a database and then populating it with the fake data that I've made. Then you can really play along. So we might go there at some point, perhaps in our next course or perhaps not then. So onto the schedule. We've done 7:13, we've done 7:20. I canceled 7:27 because I had kind of a full week at CWI. We're doing 8:3 today. 8:10 is my birthday, and I will not be here. And then 8:24 I've just crossed out because I'm going to be on CWI again for the first week. So far I'm planning to do 8:17 and 8:31. With every other week schedule is kind of working out. And then by 8:31 at the latest, I will have the next class schedule prepared for you all. So everyone prepare to come 8:17 and 8:31. That's all for house cleaning. Tables. We're going to talk about all of my tables and how tables relate to each other, because this class is about relational databases. So first off, a table is a table. And if you don't know what a table is by now or by the end of this class, please reach out to me and we'll talk. A list is a table of many rows and one column. So for example, this guy here, this list of names is a one-column table. And you'll see how that comes in handy a little bit later. The results of a query can be treated as a table. We'll see what that looks like too. And the results of a query is going to be either a table or a list, but a list is a table. So the results of a query is a table in a way, at least temporarily. Finally, and we haven't even touched on this yet, but we will, views, CTEs, or common table expressions, and table-valued functions can also be treated as a table. So there's a lot of tables here. Just a recap of what a table is, we have columns and rows. Our columns are our student ID, our first name, our last name, that's in the students table, and then our address ID, student ID, city, state, other stuff in our addresses table. One thing you might find interesting about my addresses table is that I've got this student ID column, and this is how we relate the addresses table to the students table. So I've got Edwin Millard here, student ID 112233. We can tell from the student ID value in addresses that Edwin Millard lives in Riverside, California, and that Clara Pratt with 112234 lives in Portland, Oregon. Look at that. So what we can say is that the students table relates to the address table, and that relationship is students.studentID equals addresses.studentID. We're going to get way into this in a bit. What we'll be covering today in our relational table talk is all of these tables that I've sort of just made up for my fakie test database and all these relationships. So first off, I've got my students table and my addresses table, which I just covered, where student ID in the students table relates to student ID in the addresses table, or the students table and addresses table relate via these two columns. And then I also have this other table called enrollments, where my student ID and student ID, students.studentID equals enrollments.studentID is my relationship. So I've got this students table and these two tables that are related to it. Then I've got my courses table, which is also related to my enrollments table, as you can see, and then to a terms table where I've got a term here in courses, but then I've got more information about the terms here in this terms table. So as you can see, this enrollments table is just sort of the glue. There's really nothing but IDs in here, but enrollments relates to students and enrollments relates to courses. And via this table, I can relate students to courses. So you'll see a lot of this sort of stuff out in the wild, and this is really just a taste of that sort of thing. Any sort of ERP, colleague, Genzabar, et cetera, it's going to have hundreds of such tables and relationships a lot like this. Just a quick aside in my diagram, I've got this, what's it called? It's called crow's foot notation, where students to addresses, one student might have many different addresses, a mailing address, a permanent address, et cetera. And then one student may have many enrollments. A student's going to be enrolled in several classes. By the same token, a course might have several enrollments, several students' enrollments in it. So what I have here in this notation are these one-to-many relationships, but via enrollments, students has a many-to-many relationship to courses. You don't necessarily need to know those terms, but you might hear them in your life. So I thought I'd bring that up. The nice thing is that all of this database stuff, for the most part, relates to real life. So you can say to yourself as a higher education employee that there are many students to many courses and vice versa. There's nothing really terribly abstract about any of this when you think about it. All right. Time to get real. Get rid of that. That's my practice. So just a little bit of a refresher on students and addresses and courses. This is sort of what my table looks like. So if I say select star from students, as you can see, I suppose I was fairly lazy in setting up my fake data. I do have a lot of rows at least, but I didn't go too crazy. No, that wasn't laziness. That was to keep this simple. Okay, so I've got my student ID, my first name, middle name, last name, date of birth. If I look at addresses, I've got an address ID, I've got a student ID, and as you've seen, that's how we relate the addresses table to the student table. And I've got some other basic address stuff, street, city, state, etc. Address type, I've got M and P for mailing and permanent. We'll look at that in a bit. And then I've got select star from courses. I've got a bunch of courses here. I've got an ID, I've got a code, I've got a name, I've got year and term, etc. And then I've got enrollments, can't type. And enrollments, as you can see, doesn't have much of interest really by itself, but I have a student ID and a course ID, which means I can relate my enrollments table to my students table and to my courses table. Okay. So there are many ways to relate tables together, and I'm going to start off with sub-selects. So as I mentioned earlier in the PowerPoint presentation, many things in SQL are treated like tables. So again, if I do select star from students, students here is a table. But so too are the results of my query. This is a table. That doesn't seem like much of a distinction, but it will, just a second. If I change select star from students to select star from students where last name equals Jones, here are my results, and I can pretend these results are a table. So these are all my students where the last name equals Jones. If I wrap this up in parentheses and say select star from, now instead of saying select star from students, I'm saying select star from this query. And one little quirk in SQL Server land is I have to name this. So this query can be treated like a table, but I have to call it something. So now this thing right here, select star from students where last name equals Jones, is temporarily, for the duration of this select statement, a table called this is not a table. What did I do? Okay, I didn't highlight it all. All right, now let's look at addresses. So as you can see, I've got all of my address data, but I also have the student ID that helps me relate addresses to students. So say I want to find all addresses, I'll go ahead and get rid of this, all addresses where city equals Austin. Great. These are all the addresses where the city equals Austin. But now say I want to get all students who live in Austin or who have an address in Austin of some sort. I can say select student ID from addresses where city equals Austin. Great, I've got students. But say I want to get not just student IDs, but student names, student birthdays, etc., but only for students who live in Austin or who have some sort of address in Austin, mailing or permanent. What I can do here is I can pretend that this is a table. Let's call it Austin addresses. Oh, doing the wrong thing, sorry. Look at this, look at the results of this. I've talked earlier about tables and lists. Now a list is a table, but a list is special because a list is a single column, multi-row table. So what I'm going to do is I'm going to say select star from students where, and I'm going to do something really quick to just call it back to a previous class, where student ID in etc. I'm saying look at all my students where the student ID is in one of these. So basically you can read this as student ID equals 74105, student ID equals 83950, student ID equals 839521, one of those. So I run this and I only have that one. That just means that these other students don't exist. But instead of this list here, I can replace this list with this query. And this query returns a list here. And check it out. So these are all of the students I have who live in Austin. Now, this might be a little confusing, but that's just because in my fake data, I have a whole bunch of addresses with student IDs that don't actually have associated students with them. I also have a whole bunch of students that don't have addresses. We're going to go over how to look at that a little more thoroughly in a bit, just because I've been involved in this data cleanup project. I wanted to show you what bad data looks like as well. But I digress. Here are all of my students, their first name, their middle name, their last name, their date of birth. But we're getting this data from students based on the presence of students in the addresses table.
So why didn't we have to give that one a temporary table name?
That is a good question. That's a very good question. And the answer is because. Two different things.
Thanks, Dad.
If I'm selecting from a table, from a query that's pretending to be a table, like a multi-column table, I have to give it a table name. If I'm selecting from a query that is acting as a list, where basically I'm using the N clause, I don't have to give it a table name. Why that's the case, I'm not really clear, but I can demonstrate this here. This is just a choice that they made. Not every SQL flavor do I have to give it an alias. Like in Oracle, I don't have to give it an alias. In fact, when I used to go back and forth every other week between working for an Oracle client and a SQL Server client, that would always trip me up. It still sort of trips me up. But if I do this, check this out, just to demonstrate how the syntax works. Let's do a couple of these. This is a list, just like this is a list. and I don't have to give this list an alias. However, if I did something like select star from, and here's my little fake table, I do have to give it an alias. Does that make perfect sense to me? No, not really. Other flavors of SQL don't require this alias, but for whatever reason, Microsoft SQL Server does. So when you're doing in, there's no alias. When you're doing from, there is an alias. And that's just something you're going to have to remember. Rob, I anticipated your question and did some research on it and didn't find anything more satisfying than that.
So it's not related to how many columns of data or how much data is in that little subtable or query result?
It's not related to how many columns, no, because as you can see, this little subquery, I could do more. I could say city, state.
Versus from? Okay.
It's really just in versus from. So basically, my answer, my slightly more technical answer, is that lists can be anonymous, as in they don't have any sort of name, but tables, even temporary tables like this, can't be anonymous. They have to be given a name of some sort. Even though that name only lasts for the duration, is only valid for the duration of the select query, it still has to have a name. And what's cool is I can do, not cool, what's something, I don't know what it is. I can refer to a.studentID, a.city, a.state. So if I'm selecting from multiple tables, and we'll see what selecting from multiple tables looks like in just a minute here, I can refer to, say I've got a couple of subqueries here, and both subqueries have student ID, city, and state. Well, I can sort of qualify which one I'm looking for by this table alias. So here I'm saying specifically, give me the student ID that exists in this fake temporary table that I've decided to call A. If I change the name to a dumb table name, this is going to stop working, as you can see immediately from my syntax highlighting. But if I change this A to a dumb table name, good. There we go. So really easiest way to remember it is just in doesn't need a table alias. In fact, can't have a table alias. And from can and must have a table alias. So just remember that. Okay. One more example. So everything's a table. Go to courses, select star from courses. Again, here's my course ID, course code, course name, etc. And then select star from enrollments. I've got my enrollment ID, student ID, course ID, nothing terribly interesting. Now what I can do here is say, I'm going to just Julia Childs this bad boy and copy paste it in. What I'm asking for here is all of my students who are not in is just like in, except the opposite, this other subquery and then this other subquery. So I'm going to break this down for you. So So let's look at my select star from students where student ID not in, and then I've got this whole subselect here. I'm just going to push enter here to illustrate what we're working with. So now here I've got select course ID from courses where course name like math. Here are a bunch of course IDs. Now I've got this other query right above that. And again, this is just using the in clause, so not the from, meaning no aliases. Select student ID from enrollments where course ID in this list. So now if I run this whole thing together, I've got all of my student IDs who have an enrollment in a math course. And then if I go even further up, I say give me all of my students who are not among this list of student IDs who have an enrollment in a math course. And there I go. Here's every single student who is not enrolled in math of any sort at the moment. So I can do ins all the way down, as you see. Let me just go back to students and addresses just to sort of illustrate a little bit more what I'm looking at. If I do select star from students, where student ID in select student ID from addresses where city equals Austin. I can run this, but the only reason this works is because the in clause requires a list, and this subquery here is a list. If I said instead select star from addresses where city equals Austin, I get a bunch of data here. This is no longer a list. This is a proper multi-column table. And if I run this query here, I'm going to get an error. And the error makes sense. It doesn't always. Only one expression can be selected, specified in the select list, etc. We'll cover this at some other point. So this has to be student ID. This has to be one value, a single row list. One other thing that you might find yourself doing on accident that'll trip you up. If I say select address ID from addresses where city equals Austin, I get a bunch of IDs. These don't really look that much different than student IDs. They're just generated fields that uniquely identify a record. If I run this query here, I'm going to get some results. And so on first blush, this query is fine because it's syntactically correct and it runs. However, the address ID column in my addresses table has nothing to do with the student ID column. Any resemblance is purely coincidental. So if I run this, this data looks real, but it's completely meaningless. I have to do select student ID from addresses because only through student ID do students and addresses relate to each other. I bring this up, I don't think, you might be thinking like, why would I ever do something like that? That doesn't make sense, but it happens. It happens a lot in the real world. I've seen it in reports that I've debugged, some of them my very own, where I'm just relating some ID to some other ID and getting results, and I'm not getting any errors. Even though it's syntactically correct, it is semantically incorrect to do something like this. It's almost as incorrect as doing something like this. where student ID is in this select list of cities. But at least in this case, I'm going to get a syntax error because city is text and student ID and address ID are numbers. So in the homework that I assigned this week, you're going to get to play with that a bunch and see the many ways in which this sort of thing can go quite wrong. Okay, so now we're 35 minutes in, and I haven't even gotten to what I really want to talk about, which is joins. So in this case, my subselect, whether it's in or selecting from some temporary alias table, I can get all of my students here. But what if I want to get not just my students, but everything? My city, my street, my state, my country, all of that sort of stuff in this one table. The in clause here with these subselects, so far, we're only sort of concerning ourselves with the where clause. So I'm filtering my data, I'm getting specific kinds of data, but I'm not really displaying data. And so this is a perfect segue to joins. In fact, all of the stuff I've talked about with subselects, joins, as you will see, are preferable. What I'm covering in this class aren't necessarily the best practices, but it is what you are going to see out in the wild. And we're going to get into a bit more of that as well. So what I'm going to do is remind you of these relationships between the tables. So I've got student ID in students and student ID in addresses for a start. So just to get right into a query, if I say select students.studentID, students.firstname, students.middlename, and I'm already tired of typing, so I'm going to just bring this rest of this in here. From students. Okay, so the syntax highlighting in here, I already got rid of that ugly red squiggly underline. But I'm going to select from two tables, select students and addresses. Okay, I've selected from two tables, but how do I know which row in my students table relates to which row in my addresses table? By calling upon that very same relationship that you've seen, where students.studentID equals addresses dot address ID. Nope, dot student ID. See, I almost did it. Now what I can see is every student and their corresponding address. So it's in my where clause that I'm defining this relationship here. Now, there's another kind of way to do this. In fact, this is, again, one of those things that I'm showing you. Even though it's not the best practice, it's something you're going to see a lot in your day-to-day work. Reporting tools like Infomaker and Informer and Argos. I know at least Infomaker, and I think Argos join tables up together this way. This is sort of the old-fashioned way. There is a new way, new-ish, new as in like 1989 new, and it is, in my opinion, superior and correct. So here's one example. I'm going to go ahead and do another example that's correct. So I'm going to select the same fields, and I'm going to say again, from students, and instead of using a comma, I'm going to use a join. Join addresses on, and again, I define my relationship. Student ID, students.studentID equals addresses.studentID. So let's see, this one gives me how many? 4,825 rows. And this one gives me 4,825 rows. So these two things are syntactically correct, but going forward, I'm only going to use the join clause for reasons that will become apparent. But I wanted to show this because you are going to see this sort of syntax in the wild. This is the better stuff, though. Okay. And in fact, just for fun, I'm going to introduce a new piece of syntax called except, where I can take the full results of this query and the full results of this query and basically compare the two sets. So if I run this, this will say, give me anything here. Give me, what is it? Give me everything in this query that isn't also in this query. And to prove that these are the same queries, in a sense, I'll run this, and I see nothing. This except clause, this is sort of a tangent, but I use this a lot in my work if I'm recreating someone else's query to use different tables or different syntax or something like that. But I know that the results of the original query are actually correct. I will run the first one and accept it over my second one just to make sure that I'm working with the same two sets of data. Okay, so on to joins, and this is why join is superior, because I have several different kinds of joins. I have, using comments, my inner join, my left outer join, the right outer join, my full outer, cross join, and my self join. So we're going to cover all of these. These 5 are really the fundamental types of joins. This is sort of a special case. The join that I just did is an inner join. I'm going to go ahead, copy this, go through all of this. So this is basically the same query that I put in just a second ago, except I'm using the full syntax. This is something where if you look at my queries and you look at, say, Eric Larson's queries, you're going to see something sort of different. Eric Larson's is probably the better way. Inner join is equivalent to join. I use join as a shortcut because I don't like typing very much, but inner join is the full name of a join. The shortcut for left outer is left. The shortcut for right outer is right. You'll see a lot of this in the wild, and you'll see a lot of this in the wild. Just know that these are equivalent. This is just sort of syntactic sugar for me to allow me to type less. But going forward, I'll give you the full names. So I run this. I get 4,825 records like before from students, inner join addresses on students.studentID equals addresses.studentID. Now here's where it gets interesting. In my data, I mentioned just a little bit ago that my data is a bit junky, but you'll see this sort of thing even when data isn't junky. I can run this same query, except instead of inner join, I'm going to use left outer join. What this does is it says give me every record in the students table that has a corresponding record in the addresses table based on the students.studentID relationship. Students.studentID equals addresses.studentID. What I do here with my left outer join is I say give me everything in the students table and their addresses if they have an address. But if they don't have an address, still give me the records in the student table and just put nulls in for city and state. So if I look at this table where I'm doing an inner join, every single one of these records has a city and a state value, and I only have just under 5,000 rows. But if I run this one, I have quite a few more rows, 82,000 plus, because I'm getting all of the students, and I'm saying, if they have an address, show it, great. If they don't have an address, just put null. And we covered null in the last class. Check out that video for a refresher if you want, or the homework. But this gives me all of my student records, whether they have an address or not. That's left outer join. You're going to use this a lot. For completeness sake, let's see here. No, not for completeness sake. I'm going to spend some more time on this left outer join. So this is every student, whether they have an address or not. And this is where it gets handy. I can say, give me all students that don't have an address record. That gets sort of interesting. So, because you probably want students with an address record. Now, I don't know what you're going to do with this data. You might copy it to an Excel spreadsheet and give it to your registrar and say, hey, figure out the addresses for all these students. I don't know. That wouldn't be very nice, but you could. So I'm going to say where addresses.studentID is null. This is 82,000. Now I'm going to run this, and I'm going to get about 77,000. That's a whole lot of students that don't have addresses. That's some pretty bad data, but that's okay. This is how you find all students that don't have a corresponding record. You left outer join to addresses, and then you just filter by all the things that's null. This addresses.studentID is null. I could do any field in addresses. I could do addresses.city is null. 77,000 addresses.state is null. What I do as my null statement here doesn't really matter, because when I'm doing a left outer join from students to addresses and there's no corresponding address record, every single column and address on the address side is going to be null. Let's see here. Now let's go back to our inner join. Delete this. In my inner join, I'll say where addresses.state equals California. Let's find all of our students who live in California. I have 359. If I change this again from an inner join to a left outer join, what this is saying is give me all of my students who either live in California or don't have an address. So 359 for my inner join and 359 for my outer join. What I wanted to say was give me all of my students where they either live in California or they don't have an address. And that doesn't seem to be happening here. None of my cities or states are null here. The reason is the left outer join says, give me addresses if they have a corresponding student record, or give me null. But then this where clause further filters that down to say only where addresses.state equals California. You see, again, if I run this, I've got either addresses or no addresses if there's no corresponding address record. But once I add this, I further filter it down and I make it pretty much equivalent to the inner join. So what if I want to say, if I really want to say, give me all students where they either live in California or they don't have an address at all? What I have to do is take this address state equals California out of the where clause and in to my left outer join clause. Pretty subtle difference, but this and is now associated with this on. So if I run this, I have everybody, either who doesn't have an address or who does have an address, but they live in California. Pretty subtle difference there, but it's an important one. If I'm outer joining on a table, but I want to ask some questions of that table, I have to put my where clause within the join itself. Now after this, I can put a where clause, students.last name equals Jones, maybe. This might not give me any results. It does. All of my Joneses who either live in California or don't have an address. I bet none of them live in California. Okay. That's kind of hard to explain, but playing with it, playing with real data is going to be really helpful. This class really, again, is about letting you all see the syntax and giving you sort of a taste of it, but really getting sort of the muscle memory is the way to go. Now, what I haven't covered yet, and I'm not going to cover, is the right outer join, the full outer join, the cross join, and the self join, because I think we should save that for the next class. And I think the next class really warrants even going over inner join and left outer join again. The join stuff is probably the hardest part of SQL. So why not repeat it, I think, and maybe go a little deeper into it. So I'm going to go ahead and stop talking now, open the floor to questions, and we'll plan for the week of August 17th to continue our joins discussion.
Could you just go over one more time why, even though it says and addresses equal California, that null is being returned when you've got a statement that selects it to California?
Exactly. So very good. So what we're looking at here is this whole statement. If I didn't have this, let's take this out. Who is that asking, by the way?
It's Kara.
Hi, Kara. Thank you for asking the question, first of all. What I'm doing is when I say left outer join, I'm saying give me everything in the addresses table that either relates to students on this relationship here, students.students.id equals addresses.studentID. And if there isn't a record of such a relationship in the addresses table, just give me null. Now, does that part make sense? Just the basic left outer join there.
Yep.
Okay, good. Give me all of my students and give me any corresponding address record if it exists. Still give me my students if the corresponding address record doesn't exist. And if it doesn't exist, just give me null. Now, if I add this here, just forget this bit for a minute. This and clause falls into sort of the same jurisdiction here. So now instead of just this relationship student.studentID equals addresses.studentID, I also have the and addresses.state equals California. So what I'm saying is give me everything from addresses where the address state is California. But I'm still saying give me all of my students and give me everything where there's a corresponding student record and there's a address in the state of California. If there isn't, just give me null. So this sort of becomes like a special table. So this thing here turns into something like this. Select star from addresses, where addresses dot state equals California. So this is all of my addresses where the state's California. This is essentially the table, because remember, the results of a query can be treated like a table. This is essentially a table. And so what I'm saying with this statement is give me all of my students no matter what. If they happen to have an address, and if that address happens to be in California, show that. But if not, just show me null. And if that doesn't make sense, that's okay. We'll keep at this.
So, Michael, this is Phil. You'll have students in there that may have an address, but they don't have an address in California in those results that you have there.
Right. That's right. That's right. That's exactly right.
Great.
Yep. Yeah, if we really want to get like, thanks. I did sort of misstate that actually. If we really wanted to get either an address in California or no address at all, but no students that have an address that isn't in California, that would be slightly different. And maybe I'll go over that the next time. But thanks. That's a very good point, Phil.
This just returns all null and all California.
Yep, exactly. That's right. So yeah,
So
you're totally right. Yeah.
Can you stick a distinct in there so you could see that, or count or something?
I'm not going to do a count because that's for a later class. I don't want to get ahead of ourselves. If I said it's distinct, that wouldn't really work either because I've got first name and last name. What are you looking at, Joanne?
No, I was just curious to see that, I guess. Oh,
what I can do is order by addresses, not statute, state. And so if I go to the very bottom here, here are all of my California addresses, and then further up, all of my null addresses. Yeah, when we get into counting and summing and minning and maxing, it's going to get super interesting. But yeah, I don't want to get ahead of ourselves. 5 minutes talking about counts would be a disservice. Any other questions about this? I'm going to give this a whole other hour because joins deserve it. Try not to give it 2 whole other hours, but this is your introduction to relating tables to other tables. Do you have any other questions?
I'm glad you're repeating it for a second session. You're right. We need to
I know, right?
But thanks, and I've got to run. I've got another meeting to go to. Thanks a lot.
Absolutely, yeah. But yeah, everyone, to echo Rob, I'm just realizing this, and as I was putting this particular session together, having someone talk at you for an hour about joins, really just half an hour, is way not sufficient. So start off with the homework at the very least. Again, I'm going to post this on the SharePoint site, but please just reach out to me. All of this homework's on SQLzoo.net, so spend some time there if you can. Start struggling with this. Start working on this, and write me and ask me questions, because not only are you learning how this all works and how this all fits together, but I'm learning how to explain these concepts as well. So the more questions that you email me, the better I will get at explaining it. For starters, Patricia's going to help me work on getting a forum set up. But for now, if you email me a question, it's probably going to be a good question. Don't be afraid, even if it sounds like a bad question. And chances are I'm going to use this in my next class, any questions that you email me. So please help me teach the class. Help your coworkers by helping me give a better lecture by emailing me your questions. And the best way to get these questions is to either struggle with this homework on SQL Zoo, or if you do have access to a database wherever you are, give me some real-world queries and I'll help you through them. This is what I'm supposed to do, and it's what I want to do. So with that, I'm going to go ahead and stop the recording.